Hello everyone. This is another tutorial which we will retrofit an existing beam which previously we model and simulate, and we got the uh, curve of force displacement curve, and I'm gonna plot it, and here is create another operation and using combine, giving -1 times the u2 and comma -1 times and now I can call it FED, force displacement curve, and now plot, and this is the curve. Now what we're gonna do is we want to retrofit this existing beam using CFRP material. This is a CFRP material, and the thickness of the CFRP is 0.146 millimeters. So we will consider each layer a composite of each layer. So then you can say the total equal this one times 0.146. So it's 1.4 millimeter. This is a very tensile, with a very high tensile strain material we want to retrofit, and then after the analysis completed, and we want to compare the results with the uh, existing beam, how this CFRP can improve or enhance the beam load bearing capacities. So we go back to the part, uh, because we already created beam concrete beam, rebar, and straps and support. So I suggest you to watch this in the 3-point bending loading tutorial, and then come back and just create one more called CFRP, uh, carbon fiber reinforcement polymer, and then select the shell, and you can give at least we want 5,000 and use extrusion. Now here the size of the this CFRP is equal to the size of the concrete. The size of the concrete was 200 width and 300 depth. So and I could give -100 and comma -150. So this is the first point. The second point is 100 and 150. So we created the section and we want to extend it to 2 meter, 2000 millimeter. Now we created the CFRP or another box. We go to properties. In the property, we should create a material for fiber elements. So for concrete, we have CDP, which has a 25 kilo megapascal, and steel rebar, which has ultimate strength of 410. Now in my library I have some material. I can see here is a CFRP. I want to add it. I will give this material to you. You can use in your project, or this is here in Excel sheet, and you can check some other resource or experiment, then you can find out these parameters, or consider to look in the manufacturing company's catalog. So they have the CFRP parameters and also the thickness, everything. So we go to here and check the what is here. So we mostly use ashen. You can come here, and here is called fiber reinforcement. So ashen is much more proper for this kind of composite material. In the ashen damage, here is we have elastic first. In the elastic we have two choices to select, one engineering constant and luminar and density. Here is to another parameter, damage stabilization. You can consider some damage stabilization. So here is 0. You can give based on your experimental data. And here is damage evaluation. So we're considering the longitudinal tensile fracture energy and also the compressive fracture energy, transfer shear fracture energy, and also the transfer compressive shear energy. And also we considering the damage evaluation and also the action parameters. Okay, and in the section we should create a composite section or composite lay. So I already said it's 8 layup, 8 going to use conventional shell, and here is so in the here I can select all, and in the region I can right click and call edit region, so that region should select. This tool is in one direction, which is y, in the x, so I select them in 1 and choose this axis 2 to see that axis 2 is giving here. And now in the material, select all, define the material. So the material is CFRP, and the thickness is, I go to edit and just give that number. And the angle, the first angle is 45, 0, 45 minus 45, and 19, 19, 19, and again 45, again 45, and minus 45 and 0. And here is the integration point in case if your project is very microscale, you can consider the integration point effect. So that for this one I can change this to 5. Okay, now again the second part, just I can go to here and copy this. Here I can call 2. Now what I want to do is just in the region, going to edit region and select this one and this one. Now here is I created 2 regions. So now here the first one, and here is the second one. One more thing I should say, when we go to the assembly, let me bring the assembly here. We want to the thickness of the CFRP should be outside. So for this purpose, first I want to bring the CFRP, okay, and I want to rotate. Before the rotate, I want to rotate first, and this is the rotation, and then I want to take move and taking this point to this point. Now I want to turn on the assembly called rendering shell, apply. So I want to see some, let me go to section instead of section part, and we can see one is the red one uh, in the part, the green one is concrete, and the white one is CFRP. So let's see here, and the problem is that the CFRP is taking center to center, so we want that should be uh, outside of the concrete. So for this purpose, we go to the here in the first one. Here is called offset. So we want to select bottom. Let's see how it works. So both are using called offset bottom surface. Now we go back to the assembly, and let's see it's changed from inside to outside. In the both area, it's showing outside. So now properly we uh, construct the both elements together. So next, what we're gonna do is we can assembly is finished, step is already given. We created two step, and we created the two-step output. You can check in the previous. I have given complete explanation, and here is the interaction. So we want to create a contact between CFRP and concrete. So therefore, we need to choose the two surface. We have two choice. One is we can consider totally restrained, which is not allowed any deformation between or bond slip, and the second is we can consider some slip or cohesive behavior, uh, or even we can just consider the contact with a little uh, deformation. But in this tutorial, just I will consider the using the tie, which is 100% constraint, and there is no any movement between concrete and CFRP. So I can select here, create a tie, uh, concrete to CFRP. I can surface, uh, go to here first. In the part, I want to just see a replace. Now I can select the surface which I want to create a tie contact, so the entire surface should contact together except these two end. And now here press the shift to select all surfaces. So now we selected all surface, and I can go to uh, again is okay, and go to again surface. So then the second surface should be the CFRP. I go to the here and go to CFRP and going to replace. In the CFRP I can select CFRP, and the CFRP will select it. So this one it's shelled, you will select all. Now the inside is purple, the inside is purple, outside is brown. So I select purple. So now inside is selected. Now we can go to back to see all structure is together. Now here is one more thing, in case maybe we should change the connection between the supports and concrete, and also the connection between these discrete elements with the CFRP. It's okay in case if we couldn't reach and receive any error, so it's okay. Otherwise, we should change it. First, I ignore this and just I want to consider the contact between these two. It should be the concrete. Now, here the interaction is finished. We go to the load is already created. Two load, one is two boundary condition, one is displacement, and we considering this is the roller connection support. Here is the mesh, so I should mesh this element and using 4, and now it's yes, and uh, everything is done, and I'm going to job, and this is called CFRP model. So the first one is concrete and the second one is CFRP. I want to submit. Now it started running, and just wait for a while to see if there is an error we will fix. In other case, if it's start to uh, solve, and then so there is no problem. And now the first step is start 0.1 second, and there is not any error. We will let the program to finish analysis, and after it is finished, and we will check the result and make comparison together. So I will pause the video for a while. Now the analysis partially completed. It took about 0.2 seconds, but the time increment is quite small. So if I let the program to finish to solve this, it take quite a long time, maybe 10 hours or 12 hours. So I want to stop at this, kill it to see, because after this point the concrete is actually damaged, but the CFRP it has a quite tensile strength, which is not going to damage or yield. So we can go to check the results. Here is the result, and we can see the histories. Let me see just the CFRP, replace. This is the CFRP. Even we can go to command, this is about almost 280 megapascal it reach, but it should it will go to maybe 1000 megapascal. And we can go to here and the beam, and this is the beam, how the beam is behave. So it's reached to 80 megapascal with the ultimate compressive strength is 25 megapascal. We can do an animation and see how it behaves. We can check the tension strength damage. So it's already reached and so significant damages happen to the bottom of the concrete. And if I go to the last step, so this is it. So mostly it's completed. So if I go back to here, create two here I want to create one more, and then I want to use this one, and this one I want to open the visualize. Go to the first one, I go to this one, result, and this one is the concrete with reinforcement rebar, and this is CFRP. So now we can go to here and just show the concrete replace, and this is the concrete using damage. Now this one is rich because the tensile strength is quite high, and which has a contact with the CFRP, so it reached much more larger here. Even the time period is 1, which is 30 millimeter centimeters, 3 centimeter is pushed, but in here very small, because the stiffness of this beam is quite higher. Now we can connect them and showing a we created a connection. Now we can see the animation on one side, but we're not sure. Yeah, now we can see both sides and how it works. So in the first steps, so it's begin start, and this one is larger, and finally in the middle is this one is quite high, but this one is less. So this is some difference, and other comparison is on the curve. So we want to create the curve in both sides. This is the EP which is taking from the 3-point, and we want to create one from the safe from CFRP. Okay, and here is the curve from both sides actually. Now I can select this one. This is the 3-point or 3 without CFRP. Now I'm going to plot this one here, and this side here I want to create let's see, combine, and going to -1 times U2. Both are from same, but I should remove one of these, otherwise we will do some mistake. We cannot determine the exact. So now here I'm going to job and result, this one result, and going to again and creating this 3 time history output. So this is the curve. I'm going to make an operation putting combine and -1 times U2, and again comma and -1 times REF2. So now save is called CFRP FET. Now we can plot this together. So here is the response of both beam. One is the reinforcement concrete, and the second one is which we provide uh, CFRP. Now we can see exactly it's changed by 100%. So it's about 7 and it's almost 20 megapascal, 20, almost 200 kilonewton. So this is the resistance force. Uh, okay, this is the comparison and also we graphically shown. Now if you have any question, please put in the comment and I will find time to answer you. See you next time, and you can find this tutorial files in the description link, and you can leave the analysis completed, and finally you can make comparison. See you next time.